Hi everyone, welcome back to P4. So in P3, we introduced polynomials and we introduced how to do some operations on polynomials, which included expanding and multiplying and adding and subtracting and all sorts of different things. And what we're going to do here in P4 is the literal opposite of expansion. So some basics: factoring is the reverse of expanding and foiling expressions. We learned how to do x plus 3 times x minus 3. This is FOIL, so we do x times x is x squared, x times negative 3 is negative 3x, 3 times x is 3x, 3 times negative 3 is negative 9, and then we see that negative 3x and plus 3x can cancel out via combining like terms, so we can go from x plus 3x minus 3 to x squared minus 9. However, how do we go back from x squared minus 9 to x plus 3x minus 3? And that's called factoring. So when a polynomial is factored, the terms in the product are called, believe it or not, factors. So the first type of factoring we're going to do is greatest common factor, or GCF, which is the simplest form of factoring. And a GCF contains two things, at most two things. The first thing it contains is the largest integer that divides both terms' coefficients, or multiple terms' coefficients. Okay, and then it also contains the smallest exponent that appears in every term's variables. So this is very wordy. It'll make more sense in just a moment. But for the second part, kind of think of the question that's like, how many months in a year have 28 days? Well, all of them have 28 days. So that's kind of what's going on here in number 2. So let's get right into some examples. So we have 9 plus 18y. Our GCF is going to be the highest number that can divide both 9 and 18, and the least common power of y's that we see. So, well, the highest number that divides both 9 and 18 would be 9. And then what power is in common of y? Well, 9 doesn't have any y's, so we can't factor out a y. Okay, so that means 9 plus 18y. When we factor out a 9, what we're really doing is dividing everything by this GCF. So we take both terms in the original and divide them by our GCF. We see 9 divided by 9 is 1, 18y divided by 9 is 2y, and this would be considered factored, fully factored via a GCF. And if you want to prove whether or not what we have is correct, think that if we were to redistribute 9, 9 times 1 is 9, 9 times 2y is 18y. So we are taking out this factor to make everything on the inside a little bit smaller. Now, you don't necessarily have to show this middle step right here. I'm showing it here so that you understand what's actually happening in this step. But if you can jump right from 9 plus 18y to 9 times 1 plus 2y, that's totally fine as well. 2x squared plus 6x. The GCF, again, is the highest number that can divide the coefficients and the least common power that they both share. So in terms of numbers, what number divides both 2 and 6? Well, 2 divides 2 and 6, so that'll be part of our GCF. And then what power do both x squared and x have in common? Well, again, kind of thinking like the months question, there are 28 days in every month. There is 1x in every term. So what do they have? What do they share? What do they have in common? Just a single x, no higher power. This one has 1x, this one has x squared. We can't take away more x's than what we have in this term, so our GCF is going to be 2x. So we take out 2x, and again, what we're doing is dividing all the original terms by 2x. So 2x squared divided by 2x, 6x divided by 2x. Well, this looks a little complicated, but 2 divided by 2 cancels out. X squared over x, one of the x's cancels out. 6x divided by 2x will be just 3. So this considered fully factored, the fully factored version of this right here. All right, let's keep going. 5x to the fourth plus 20x squared plus 25x. Okay, well, what number divides all of 5, 20, and 25? Well, 5 is the biggest number that can divide 5, 20, and 25. Nothing bigger. And how many x's do they share? Well, this one has 4 x's, this one has 2 x's, This has just a single x. Well, we can't take two x's out of a single x, so they only have one x in common. From here, we take out 5x and divide every term by 5x. 5 over 5 is just 1. X to the fourth over x is x cubed. 20 over 5 is 4. X squared over x is just a single x. 25 over 5 is 5. And those x's cancel out. So again, this factored version of the original. 7x to the fourth plus 3x cubed plus x squared. All right, well, the GCF is the highest number that divides 7, 3, and this imaginary 1 right here. Well, the only number that can divide 1 is 1, so there is no biggest number that can divide 7, 3, and 1. So we can't take out a coefficient. However, notice that we have 4x's here, 3x's here, and 2x's here. They all have at least 2x's. So we might not be able to take out a coefficient, but we can take out a pair of x's. And again, divide everything by this GCF. X to the fourth over x squared. 2x's cancel out. We're left with 7x squared. X cubed over x squared. 2x's cancel out. So we're left with just a single x. X squared over x squared, just 1. Okay. Some more examples. 16x cubed plus 24x squared. What's the highest number that divides both 16 and 24? That would be 8. And how many x's do they share? 2 of them. So we take out 8x squared. 16 over 8 is 2. X cubed over x squared is just a single x. 24x squared over 8x squared. X squareds cancel out, and 24 divided by 8 is 3. 5x plus 3. Well, 5x plus 3 is going to be just 5x plus 3. The GCF is just 1. If we can't reduce it, right, well, there's no number that divides both 5 and 3 besides 1. And this only has an x, and this doesn't have an x. So we're kind of pulling out a 1, but that's not really all that exciting. So in the event you have a polynomial or an expression that cannot be factored or cannot be reduced, it is irreducible. So a factor is irreducible if there is no GCF, or in other words, a GCF of only 1 and negative 1, right? You could infinitely take out 1 every single time. It doesn't change anything. You can infinitely take out negative 1, and all it would do is just change the sign each time. Not very exciting to us. So the factor is irreducible if there is no GCF besides 1 or negative 1. 5x plus 3 is irreducible since 5x and 3 don't have anything in common. However, 6x and 6x plus 3 is reducible because 3 divides both terms, right? We could still take out a 3, and even though we can't take out an x, we can still take out a 3, and 3 isn't 1 or negative 1. We say an expression is factored completely if the original expression is written as a product of irreducible factors. So if we can write our thing as a bunch of irreducible factors, then we know our job is done. So for example, looking at some of the original examples, there's nothing else we can factor out of here. So 8x squared is irreducible, 2x plus 3 is irreducible. We would have considered that factored completely. So, for example, 3 times x plus 2 is factored completely, but 2x plus 4 times x plus 3 is not, because we can still pull a 2 out of 2x plus 4. Well, after GCF, the next simplest form of factoring is factoring by grouping. And we're going to do a lot of factoring by grouping in the next example or next type of example. So we're only going to do one example here, but let me explain what's happening. So if all of the terms in our polynomial have a collective GCF of 1, what we can do is split the terms in half and factor each pair separately, or each half of our polynomial separately. Well, if a polynomial can be factored by grouping, then what we're going to get is that the terms remaining inside our parentheses after taking out a GCF will be the same. If they're different, then that means either your polynomial can't be factored by grouping, which happens plenty of times, or then you made some kind of error. So let's see what we got. So 6x cubed minus 3x squared minus 4x plus 2. Notice they don't all have an x, so we can't take out an x. 6, 3, 4, and 2. Find me a number that divides all 4. Well, the only one is 1, so that's not going to work. Okay, so what we're going to do is split these terms in two. Let's split up 6x cubed minus 3x squared and negative 4x plus 2 into each separate half. And now what we're going to do is factor each separate part using a GCF. So 6x cubed minus 3x squared, we can take out 3x squared. Negative 4x plus 2, we can take out a 2, and we're left with 3x squared times 2x minus 1 plus 2 times negative 2x plus 1. Well, I just want to stress this. We want the inside of our parentheses to be the same. In this case, they are not quite the same. So what we can do is factor out a negative 1 from negative 2x plus 1, or originally just factor out negative 2. And now the insides of our parentheses are the same. Now, how we continue from here is technically this. It is the inside of the parentheses times everything left over. So our answer is 2x minus 1 times, 2x minus 1, I think I said that right, times 3x squared minus 2, everything that was left over, 3x squared minus 2. Now, to give you a little bit of proof why, if this seems confusing, don't worry. Odds are you're never going to do this middle step, but let me just show you what's happening here. Let's just say that we have some letter C representing 2x minus 1. Well, this would be 3x squared times C plus negative 2 times C, or just negative 2C, right? 2x minus 1 is C. Well, notice these two terms have C in common, so we can factor out a C. Well, what was C? We initially replaced 2x minus 1 with C, so we can just replace 2x minus 1 back in for C. Now, again, you can see why. Our final answer, once we get here, is everything written in parentheses, 2x minus 1, times everything left over, 3x squared minus 2. Okay, and I know that seems a little confusing because 2x minus 1 appears twice, and then it only appears once. Well, that's because we can factor out the entire term, 2x minus 1, from both of these separate added terms. Okay, so those are the basics to factoring, and you think that we need more examples of factoring by grouping, except we're going to do a lot of them in this next method. So AC method is a way for us to factor quadratics, things that are ax squared plus bx plus c. Notice that I said ax squared plus bx plus c, and this method is AC. So this is how I learned to factor, and I find this way very concrete because it's going to work almost every time when it's supposed to work. However, I know I have met plenty of people that do not like this way. So if you have a different way of factoring that gives you the exact same answer, your way is completely correct. So let's do it this way. So again, like I said, it's the best way to factor in my opinion. And if a polynomial can be factored, this will always work. So for polynomials of the form ax squared plus bx plus c, these are technically quadratics, things that are to the second power. We haven't really used that term yet, but that's okay. We'll come back to it. So in the case where we have ax squared plus bx plus c, we're going to take a and we're going to take c. So not the x's, take the coefficient a, take the constant c, and multiply them together, which would literally be AC, right? A times C, AC. Okay, there are factors of A times C that when you add them, they add to B. So they multiply to AC, right? We want them to multiply to this number AC. But when you add those factors, they add to B. So we're using all of A, B, and C here. Okay. So we find this set of factors and we rewrite B as this sum. So it's going to sound a little complicated to start. When we do examples, it's going to make a lot of sense. So let's factor x squared plus 8x plus 15 using the AC method. Okay, so don't forget, this is ax squared plus bx plus c. What is A? What is C? A, as we see up here, A is the coefficient attached to the x squared term, and C is the constant term. So the coefficient attached to A would be just 1. This is like 1x squared. And C is our constant at the end, 15. So then A times C is 1 times 15, which is just 15. Now, we're going to find factors of 15 that, again, they multiply to 15, that's the point. But when we add them, they add to b, in this case, 8. So multiply to AC, but add to b, which is 8. Now you could take a second, figure out the factors of 15 that add to 8, and you would get 3 and 5. So 3 plus 5 is 8. Okay. So what we're saying that we're going to do with 3 and 5 is this. 8 is the same as 3 plus 5. And from here, we know that we can distribute x. So we can distribute x to get 3x and x to 5x. So what we really did, I'm showing these middle steps right here. They're not my favorite steps, but what we really did was rewrite 8x as 3x plus 5x. But what we used is the thing that 8 is 3 plus 5. Well, if 8 is 3 plus 5, then 8x is 3x plus 5x. Okay, so what we can now do is factor by grouping. AC method relies on factoring by grouping. So let's group x squared plus 3x, and let's group 5x plus 15. Take out the GCF from these two. GCF from x squared plus 3x is just x. GCF from 5x plus 15 is 5. Okay, and now if we did this right, the insides of our parentheses should be the same, and they sure are. We saw in that first factoring by grouping example, our answer is whatever's in parentheses, write it once, times everything left over. So x plus 3, write it once, and then x plus 5. So again, everything in parentheses, write it once, times everything left over, x plus 5. Okay, we're going to do a lot of examples of this. Let's factor x squared minus 6x minus 16 using the AC method. All right, what is A? What is A? What is C? Well, A is the term attached to x squared. In this case, it'll be 1. And C is the constant term, negative 16, right? Be very careful. This is supposed to be negative 16, not just 16. Okay, so then A times C, 1 times negative 16 is negative 16. We want to find factors of negative 16 that, again, they're factors, so they multiply to negative 16, but when they add them, they add to B, in this case, negative 6. Okay, take a second, find the factors of negative 16 that add to negative 6, and you would get 2 and negative 8, or negative 8 and 2. Okay, so that means that negative 6x, or negative 6, is 2 minus 8. Let's distribute x, and we specifically chose the combination 2x and negative 8x, because when we factor by grouping, we can take out an x. When we factor by grouping, we can take out a negative 8. And now we chose this group because the insides of the parentheses are now the same. So our answer is x plus 2 times everything left over, x minus 8. Okay. One thing I'll also note is that I did 2 and negative 8, but you could very well do negative 8 and 2, even though we are reversing the orders, even though we're saying negative 6x is 2x minus 8x. Negative 6x is also negative 8x plus 2x. So if you wanted to try doing this problem with x squared minus 8x plus 2x minus 16, you would get the exact same answer. Your terms would just be written in a different order. Let's keep going. 6x squared plus 17x plus 7. Oh boy. Okay. What is A? What is C? A is the term attached to the x squared term. Or is like, sorry, A is the coefficient attached to the x squared term. So A would be 6, and C is the constant 7. So A times C, 6 times 7 is 42. And now we're looking for factors of 42 that add to B, that add to 17. Okay, well, those two factors would be 3 and 14. So that means 17x is 3x plus 14x, or likewise 14x plus 3x. Let's factor by grouping. We can take out a 3x from these two. We can take out a 7 from these two. And again, if we did this correctly, the insides of our parentheses are the same, which they are, which means our final answer is everything in parentheses times everything left over. And that's how AC method works. I think we got one more example, so let's do one more. 20x squared minus 7x minus 6. Okay. What is A? What is C? A, again, attached to the x squared term. I think my camera might be covering it. That's okay. A is 20 and C is negative 6. So A times C is negative 120. Find factors of negative 120 that add to B, negative 7. All right, not obvious right away, but it is negative 15 and 8. Or again, it could be 8 and negative 15. The order as doesn't exactly matter, right? If you did 8 and negative 15 instead, all you would get is a slightly different ordered answer at the very end. So that means negative 7 is negative 15 plus 8, or 8 minus 15, same thing. Well, negative 15 plus 8 times x, negative 15x plus 8x. Factor by grouping. Here we could take out a 5x. Here we could take out a 2. Ooh. Here we could take out a 2. And then we have everything in parentheses is the same. So our answer is everything in parentheses times everything left over. Okay. Well, let's wrap up P4 with just some formulas. We saw toward the end of P3, toward the end of polynomial operations, is that there are some very special types of polynomials. For example, we had a rule for a plus b times a minus b. After we expanded that, we got a squared minus b squared, what we call the difference of squares. Well, if we're factoring, we can use that same rule just in reverse. So a squared minus b squared is a plus ba minus b. And let me begin to tell you, a squared minus b squared is a plus ba minus b is a infinitely important way of factoring. You're going to use a squared minus b squared equals a plus b times a minus b so often. So please, if you're going to commit any type of factoring to memory, difference of squares without fail is wildly important. Okay. We call that difference of squares. Difference of cubes, not as obvious. It's going to be this formula right here. I'll show you how to use this in just a moment. We call this difference of cubes. A cubed plus b cubed, almost identical, except instead of a minus b, it's a plus b. Instead of plus ab, it is minus ab, and we call that sum of cubes. So we have difference of squares, we have difference of cubes, we have sum of cubes. We do not have a sum of squares. We technically do. It requires some imaginary number stuff, not where we are in the course. A squared plus 2ab plus b squared. This is very difficult to pick out of a crowd, but this would be a plus b squared. Same thing but minus. This would be a minus b squared. So let's use some of those rules. X squared minus 4. Okay, well, x squared minus 4 is x squared minus 2 squared. This is a difference of two things being squared. So the formula that we have for a squared minus b squared is a plus b times a minus b. A plus b, x plus 2, times a minus b, x minus 2. Okay. 4x squared minus 25. Well, we see a 4, we see an x squared, we have a 25. So maybe these are two terms being squared. Well, 4x squared would be the whole thing, 2x squared. And 25 is 5 squared. Okay, so this is a squared minus b squared. And a squared minus b squared says a plus b and a minus b. 2x plus 5 times 2x minus 5. If you don't believe me, FOIL this out. Tell me what you get. X to the fourth minus 16. All right, well, this is kind of weird looking, but x to the fourth is like x squared squared. Ooh, using rules of exponents. And 16 is 4 squared. Okay, well, this is, again, a squared minus b squared. So a plus ba minus b, but we're not done because x squared minus 4, oh, we had that all the way up here. So notice nothing we can do to factor x squared plus 4. You might want to do x plus 2 times x plus 2. That's not going to work. So feel free to tinker around with something like x squared plus 4. You will see you can never get it to factor. So fully factored version of x to the fourth minus 16, right there. 8x cubed plus 125. Well, 8's like a number cubed, and 125 is a number cubed, and maybe this cubed is a giveaway. Well, 8x cubed is 2x cubed, and 125 is 5 cubed. So this would be sum of cubes. Something cubed plus something cubed. Now, the formula for sum of cubes is not nearly as nice as the difference of squares formula. Sum of cubes, we can look at the previous slide, but it is a plus b times a squared minus ab plus b squared. A plus b times a squared, 2x squared, so 2x times 2x is 4x squared, minus ab, 2x times 5 is 10x, so a squared minus ab, plus b squared, 5 squared. So if it helps you to label these things out as a's and b's, you should absolutely do that. Okay, so with that said, I believe that's everything in P4, and I will see you in P5. We're going to change gears a little bit. Bye.
Hi everyone, thank you so much for watching. I hope this lecture helped and that you learned something. Just wanted to give the brief disclaimer that this lecture for this section is based on and adapted from the section in College Algebra and Trigonometry, the 4th edition by J.S. Ratty, Marcus McWaters, and Leswowska-Zerpek. So just wanted to give that disclaimer. I'm not affiliated with any of the authors. I'm not affiliated with Pearson, the publisher. This is entirely a presentation and lecture I created based on the book. So thank you so much for watching, and see you in the next section.